Hello and welcome everyone. First I want to put a bit of a shout out to Peter Hansen and his extended team. Like putting on the data engineering bites and creating these communities is pretty incredible. Like I've run Snowflake user groups and Tableau user groups in the past. It's super hard work. Being able to bring this together is absolutely awesome. Look, we're kind of the new kid on the block as far as data engineering platforms are concerned. I'm not going to dive into us too much just yet. I want to talk about this concept of Agile Data Platforms because I think it's actually pretty cool, realistically. But I do want to let you know who we are and what we do a little bit before we dive into that, basically. So look, me, Andrew Montgomery, otherwise known as Monty in the industry. I've been in data for over 20 years. I talk about it more as a lifestyle choice, not so much of a career. I live and breathe this, basically. I spent a lot of my time as a data engineer. I was called a data warehouse consultant back in the day. Spent a lot of time at Tableau, Snowflake, and now here I am at Coalesce, pushing this platform out of all things. And I'm thrilled to be here because we get to bring a lot of cool stuff to you. But effectively, a lover of data. And Scott?
Hey everyone, Scott Walker, solution architect for Coalesce. Like Monty, I've lived and breathed this for a long, long time. I've been in warehousing for ages. I saw a few years ago just the power of Coalesce, and so to join the team was fantastic.
You did well. I hired the guy and I told him to say all that stuff as well. So look, let's start with this. So what we are more than anything, before we dive into the Agile Data Platform concept, we're an enterprise data engineering platform built for scale, effectively. We're very, very opinionated on the benefits of data modeling, in a sense. We also, what the key things to think about for yourselves is we really lower the barrier for entry for any data engineer to be a rock star. You know, we use a simple yet sophisticated, if I'm not sophisticated, UX and user interface to make it very easy to rapidly develop, but we don't obscure anything from you at all. We're completely transparent. My big complaint about a lot of low-code, no-code automated platforms in the past is they are black boxes, and that absolutely sucks. Well, we don't do this, but we also provide you the ability to have turnkey CI/CD, Git integration, automatic documentation, and we're growing extremely fast because a lot of our customers really resonate with what we're doing too. We get this really cool aha moment as people start to see how this works. But let's move into this because I'm not actually here to talk about us exclusively. So look, as I was saying, at some point, automation became a very scary word, and that's a fair reason as well. But we're still opinionated, and I use the term opinionated a lot, on the fact that automation saves time. And we see that all the time within all of our platforms and anything we do in our normal life. Hell, you drive an automatic car, for example. And we've been automating stuff for years, regardless, whether it's through the interface or so on. Even when I think about, if we look at this consumption side of things and automation in general, I worked at Tableau, and what I loved about the VizQL engine is, well, that's a, in sense, automation via user interface. You know, you drop a dimension, you get some attributes, whether they could be, I should say, measures, whether additive, semi-additive, and then whatever you've put on the page, it draws a graph for you. That's brilliant. That's a sense of automation too. You don't have to be a visual artist. It knows how to build that for you. That's effectively what we're leveraging too. And we're going to see a lot of explosions of automation come through with things like Gen AI and so on as well, effectively. When I really break this down in its simplest form, we're talking about augmenting the process so it's so simple and so managed that you don't have to think about it. So when I look at this image on your screen that you can see, like when you think of the EL, we've seen people like Fivetran do a really good job of just automating getting data into the platform. Don't worry about CDC, all that stuff. Don't worry about the technical debt related to it. Just get it in. Premium product, yes, but it does save people time to move on to getting into the platform. Snowflake did an absolutely awesome job of just making sure you don't have to worry about administrating your platform. And other platforms do it now too. Databricks are brilliant at this as they start to get more serverless. And everyone's getting to that point. They're all getting more agile. They're removing a lot of the debt required to actually operate them in the first place. And that's where we fit in too. We're a transformation platform, but we fit very much in automation. Around transformation, we're starting to move a little bit outside of that as well. But let's dive into this. I'm probably going to tell you a lot of things you already know, because there's a lot of smart people here who've been doing data engineering for a long time, but there's a lot of stuff that I'd like to reinforce as well. So like through my experience working at Snowflake, I used to work with the likes of Accenture, Deloitte, and Entity Tacoma across Asia Pacific and Japan, implementing huge solutions for, let's say, it would be large-scale supply chain organizations, or it could be with a single-person data consultancy. But there's one really similar constraining problem that they always ran into in order to deliver really innovative, really interesting projects. and it's always time, effectively. And this is kind of what I'm getting to with agility. It's really about the time a data engineer has available to solve business problems with data. And I'm talking about business problems, not technical. Most of your time has been burnt on the technical previously, but we're not in that world anymore. We don't have to think about it. The idea here is, and I'm not going to drill through the points, it's about using time so we can actually move to that next level. Not just doing, hell, we've got to do another lift and shift. I don't think we're in that world anymore. I think the technology's changed so far that we should be focusing on innovating nonstop at the end of the day. If we're not, then what the hell are we doing? We're still moving from old platform to a new platform, never actually getting anywhere. And this is particularly poignant when you think about what's happening in AI in general and Gen AI. So look, I was at CDAO previously, a whole bunch of leaders talking about technology and analytics and engineering and so on and what it means to them. And it's the common thread that we pull out of this is that everyone is racing to AI, but we know that we're not going to get there without solid data foundations. Everyone in this room knows this, which means it really changes the game a little bit too. It means that the most important role moving forwards in this modern data world is actually data engineers, data engineering platform owners as well too. You're the only people that are going to be able to change the world here realistically as well, or at least influence it. This Gen AI bubble, and all of us have been in technology for a while, it's going to pop. It's going to pop hard, and people are going to have to realize they need the ability to rapidly invest in their data platforms and reinforce them and actually create an understanding around data as well. But before we move even further forwards, we're going to move a little bit back in time, so to speak. So like we've been doing data development the same way for a very long time, in a sense. So I tried to structure this in a sense of looking at the evolution of data not being completely linear, because I don't think it is. I don't think it just keeps moving upwards and we keep changing and improving. I think it is spiraling. It's more like when you look at personal development. So you look at the idea of you never actually feel like you're changing. You never feel like you're actually improving. But realistically, you look back, a lot of stuff has changed and we've accumulated a lot of experience. So look at this. Let's go back to the beginning of data engineering. And I mean, my dad was a data engineer or a software engineer 40 years ago, and he would have been on Oracle version 4 doing hand coding. And what did he get? He got the fundamentals of data processing. And at that time, we were learning a lot of other stuff too about patterns required to actually implement data as well. And then what happened as we moved forwards? We started to get things like GUI tools, because obviously GUI made things faster. It made a lot of sense. But then because we'd learnt a lot about the patterns required to do this, we'd actually made a whole bunch of repeatable ways of working and routines, which if you think back now, if we're going back in time, it would have been Informatica in like 1997, for example, made it exceptionally fast to do enterprise-grade data engineering. But effectively what they built was not only a rapid way to design, but also a way to get the data modeling best practices in there. So now we've got fundamentals of processing, because we could do that by hand, and code gives you incredible flexibility to do this. And now we're getting data modeling best practices as well. And then let's move, that would have been 1997, and now I think it's like 20 years ahead. 20 years is what I'm saying. And we've got the modern hand coding tools, things like DBT, and thank God they came around, because it brought software engineering best practices to data. I do think somewhere along the line, and I'm not sure if it's more the data platforms more than the data transformation solutions that actually became the problem. Somewhere as we moved from structured data and we're doing things with Hadoop and Cloudera, we lost a lot of the data modeling skills for some reason, and I'm not exactly sure why, because they're going to become more important as people move into building trusted data with AI and getting the right results. You have no choice, it's just going to happen. But then, and I'll throw this out to the audience a little bit, because hell, why not be a little bit creative and a little bit interactive at the same time too? If we've gone from hand coding to GUIs to a modern style of hand coding, what do you think is going to happen next? Anyone? You, sir.
Is it modern GUI too?
Holy shit, this guy is good. It's a bit of a setup, let's be honest. Look, it's the next generation of this. And effectively, I'm going to break into why this is so important. It's not just modern GUIs. Like, GUI is one part of the solution. We all know it rapidly helps us work faster, but you can't solve all your problems with a GUI. It is fixed and it's defined, and it can be painful in itself. You need to get access to the code more than anything. But effectively at this stage, as we start to ramp up through this generation, and what we're seeing in new modern tools is we're seeing the idea of getting the ability to process data model best practice, the software engineering best practice, the things like Git and or even linting, which I can't believe we're doing linting in SQL, but so be it. But we're getting all the best practice. And then the idea behind this is you're getting all the speed of a GUI with the flexibility of code. But I want to have a bit more fun before we go even further. So spent a lot of time at Tableau. I used to talk about visual analytics a lot. And it's really important to kind of come back to what we are, and that's humans who live in a very visual world. So this is a bit out of date. I think a USB key uses a shitload more megabits than 125 megabits a second. But it illustrates a really key point. As humans, our visual bandwidth is overwhelmingly more, larger than the consolidation of taste, hearing, smell, and touch. Whether you like it or not, you receive information visually. And I'm going to prove this a little bit with something that I like to do for a little bit of fun. So let's try this. And I'm going to give you 20 seconds. No, I'll give you 10 seconds. How many sevens are in this set of data? Anyone? Okay, there's a few people who are close, actually, I think. Okay, and then you know what? If I leave you longer, you're going to get there without any doubt. But few people were close. It's 19. So there's 19 in there, effectively, or I've counted this wrong, basically. But the point of the story is it takes you half the amount of time once you start using things like pre-attentive visual attributes, things like color, shape, lines, whatever. And I just use color in this situation, basically. But you can all of a sudden see how important the visual is. So then we think of data. The world we live in of data in that case too. And that's a pretty weird amorphous world in the first place. When we start using visualizations, what do they mean to us in data? When we start using lines, we start using boxes, we start using connections. Well, does it look like the one that I'm seeing on, I guess it's on the left or the right? Effectively, we could use code and we can read through it and we can find the connections, and super smart people can put the connections between all these different files together and get an understanding of the environment. But visually, this is what happens when we start to use it instead. It's effectively a data model diagram. We get a picture of our data. We see how it flows. We can understand lineage and so on. There's a really key thing that I want to bring out of this as well too, about the idea of an Agile Data Platform. It's not so much about what it means to you as a developer, a smart engineer, but what does it mean as you start to work with someone like your stakeholders? Some of them are super smart and super incredible at using data, and they know how to read code, and that's great, and they understand the processes. But I hazard a guess that majority of them sit in that world where they're good at looking at visualizations. And this is something we're really opinionated at Coalesce about too. Like in our DNA is the idea of using multiple people, multiple teams, multiple projects for collaboration. And while you're doing that, making sure you can consistently see what each other are doing. So in this case, imagine you're central IT and you just want to understand where one of your source fields is going. Well, you can track it through the product, basically. You can track it through the lineage chart. What about marketing? Campaign analysis is now doing some weird things with campaigning. We want to understand how they've built some of their metrics. Well, I can look in here, I can find the transformation, I can backtrack that. You can do it with code for sure, you can do it with all the files. But like I said with that example before, the time it takes to do it is significantly less than the time it would take you to do it by hand, even if you are the best developer in the world, because you're human and you work it visually. And I'm not saying we all stop just coding. I don't think that's important. I think it's super important to have that skill. But I think the most important thing to pull out of this is you probably communicate with a computer by it being visual back to you in most cases, and then talking to it in the language it knows by getting as close to possible with coding. And that's what we do now too. Look, this is something you all know as well. If you've been hidden under a rock, maybe you've missed Gen AI, but I think it'd be even hard. I'm sure even the bugs are talking about it. Like at the end of the day, the Gen AI will improve automation, so to speak, and speed things up. Look, even for us in our tool, we build the way to do code documentation, generation, refactoring. We do it just using a sophisticated way of like an incredible backend and engineering smarts. But as tools like ours, and we will, start to use more Gen AI, it starts to speed up the development for individuals as well too. It means you don't have to write code. You definitely need to know how to read it, but it also comes with a caveat. It's still, you need to know code, and you need to write it, and you need to be skilled when you get to high complex tasks. It means 80% of the work you do can be largely automated and sped up to save your time to do high value tasks, whether they're complex or more sophisticated or AI or whatever. Or maybe they're not just that. Maybe they're socio-technical, which we'll get to next. And this is what I mean. So like have a tool generate code, have a tool generate documentation, move all the boring stuff that you as a data engineer does not want to worry about anymore, and focus on high value tasks altogether too. Because I do believe that data engineers aren't just data plumbers. Your role is far more important in organizations these days than just pumping data from one place to another. You're actually adding value across the whole value chain, across your whole business. And a lot of these skills are being farmed out. But what it means is if you start to remove all that technical burden, the technical skills you require to deliver a project, you're probably more focused on this. You're really moving to deliver business value. And this is why I think data engineers, you people in the room here, are absolutely critical to actually be able to implement AI and Gen AI. There's no one else for it. If we want this hype to be a reality, it's a case of you guys getting ahead of this and learning what are the latest platforms, latest tools, embracing what they can do, these new Agile Data Platforms, in order to solve these next generation of issues. It's you who will truly be heroes, realistically. And the thing is, we're never going to get that AI strategy if we're completely hamstrung by our data strategy. But before, I'm just going to take a little bit of a little side quest here. Can anyone remember who these people are? I think a few. Yeah, you've got grey hair like me, so I think we might have been around for a little while. Yourself, yep, it seems to be a theme turning up here. Anyone else? There's a few. Okay, we're going to do this. So these are effectively the grandfathers of data modeling, effectively. And to move into this a little bit further, we'll start with people like Bill Inman. He's the big daddy of data. They're one of the original data founding fathers. And then there was Ralph Kimball, pioneered Star Schema and the way of working. And then Dan Linstead talked about Data Vault and the way to scale up. At one point, there were religious battles fought on different platforms about what to do best. You don't actually have to know which one's the best one to use. In fact, you probably shouldn't, but you should definitely understand the importance of what they mean to your world in this day and age. Because these methodologies, which I do think have been left behind for some reason, have now become more important as we try to get truth and accuracy out of AI and Gen AI and our data in general, basically. And what about this person? I mean, this is probably more relevant. I think more people will know who this is than our other friends. Well, yep. Yeah, man, I think you might have had an Olympic skier there with Zaria Stegel, but yeah, Samek Degani, effectively. Look, and then pioneered data mesh, and this is effectively just, if we're talking about two things now, well, effectively you're talking about data mesh, the idea of it's socio-technical. It's actually not a technical solution, but it's heavily underpinned by the technology and the business process that sits around it. And to be able to do this, you need things like infrastructure as a platform, effectively something that is completely seamless. You also need to have something that is completely metadata driven, so to speak too. I was about to go rock on with my metadata driven shirt. But the idea of you need metadata, because if you're going to productize data, you need to understand everything about it as well too. But then I want to bring it to another conversation as well. So if I'm talking about things like data modeling, and I'm talking, which is effectively understanding and building the rules and understanding how to answer questions about your data in a way that makes sense to your business, and so your business understands that too, and data mesh, which is effectively scaling out data across your organization to absolutely everybody, making sure they're empowered to use data, what do they have in common? We've now removed the ability to, if we're automating a whole bunch of stuff, you're doing less codes, it's less technical. Well, close, actually. It's really business process and business value. That's what these really account to. Like if you're the sort of outcomes we're driving as data engineers now aren't so much about building a pipeline. I am talking a lot about structured environments and some of the unstructured classic data platforms, but it's not so much about building a pipeline. You still need to be complex. You still need to understand how to do it, but you're actually sitting closer to the business than you ever have before, effectively. And that's what I'm trying to get to with the idea of the Agile Data Platform. We're removing all the technical burden, the technical bullshit, so you can focus on delivering value. And I will count on these two absolute processes. They sound like data modeling is just a lost art. Data mesh sounds like a buzzword, but it's not, because every business is moving towards that goal, whether you like it or not. Hell, 10 years ago, we called it the data-driven enterprise. Now it's just called data mesh, and they've got a proper wrapper around it and a methodology. But look, starting to wrap this up, and I do want you to get to see a little bit about what we do and why that relates to the conversation we're having. But let's say, what was an Agile Data Platform again too? Look, it's effectively something that reduces technical debt, technical burden, technical complexity, so you can focus on solving outcomes effectively. And this is what I mean about agility. Agility is just saving time. And everyone's like, fuck yeah, save time. This is amazing. Now I can do more in that space. It's not about just delivering more projects. It's about doing more sophisticated projects more than anything as well too. And this is the cool thing, because once we start to save time, you get the ability to scale because you get to experiment a lot. But I also like the idea of build fast and fail fast. Also, fail cheap. If you can do this fast, then you can try something and fail and then keep moving from there too. And it means it opens you up to innovate and experiment, which we can't do right now. My main thing that I want to think about this here is that we no longer have an excuse to do lift and shift. If we can move fast, and our platform does, the likes of Fivetran made it faster, Snowflake, Databricks are doing the same thing. If they're making it easy for you to get away from all this technical burden, why the hell are we just moving one platform onto another and doing the same thing? We have the complete benefit to be able to innovate. And then obviously we do data modeling, the architecture, the strategy. You get to do the cool jobs for once. But yes, and this is where I'm going to leave it before we go into Scott and he can ad-lib over a quick demo. This is all food for thought. Like, you're all highly skilled, highly intelligent people. If I was still an engineer in this modern day and age, look, at the very least, I would experiment with these new tools, or at least parts of them as well. At least see what they're saying and see what they can do, basically, and see how it could change your life and potentially your organization. And the thing is, and yeah, I think you're going to hear me say it all the time, and I think next time you see me, I'll be wearing a shirt that says no more lift and shift, but effectively we can get away from that world altogether. And I believe it's powered by these sort of new generations of tools. All right, let's try this, and we might get the guys to switch over to the video. And I'm going to pass to Scott.
Cheers, Monty. Now for the even more fun bit. So we're going to use a quick demo to show off, a lot of the themes that Monty was talking about when we're talking about Coalesce and the power to rapidly iterate when you're building pipelines. In this demo, we're going to just show a really simple pipeline, but with some really kind of complex ideas behind it. So we're going to use LLMs to actually transform some call scripts, that's a sample bit of data in Snowflake that we're getting now, transcripts between an agent and a customer inside an organization. So we have nodes that can import the data. A node for us is just a concept of reusable pattern inside of a data pipeline. And we're going to quickly add something called a staging node, where we're going to transform the data. Underneath the hood, we're generating a lot of SQL for you, but we're using the templated nodes to standardize and really accelerate all of that. So in this one, we're going to actually filter out the German from the French and the English transcripts into separate nodes, into separate staging nodes, because the transforms we're going to do with the Cortex LLMs is going to be different for each one. We're going to translate German into English and also French into English, and just keep the English as English. So we've created those two staging nodes now, which is basically just preparation. If we add the two nodes that we're going to use for Cortex now, we select the translate functionality inside the nodes, which is pushing down to Cortex. So these are nodes that we've pre-built, and we've got a plethora of Snowflake nodes around dynamic tables and streams and tasks and Iceberg that are pre-built for you, again, just to accelerate, and you can be more highly productive in your pipelines. So we're going to set it up. In this one, we're going to transform French into English, and in the other one, we're going to transform German into English as well. And once we've done that, we're going to put those back together again. We're going to union those into one node again. So now we've got using some functions as part of our pipelines. We don't need to call on our data scientists and our ML engineers, just pre-built out of the box. We can actually start using LLMs as data engineers as part of our pipelines. And we're going to union those all back together again so that we've got a usable, single set of data to do analytics on. So really easy to do. We're just going to drag and drop those two sources together, and we're going to generate the join for us. We've got a lot of smarts under the hood to, again, just accelerate all the work that you're doing. It's going to help you do how to figure out how to join those two tables together. It knows the tables that you want to join to. And if we go back to that browser again now, we'll create those pipelines, run those, and we can start to do some even more nice analytics with additional LLMs, because why not, with the transcript data. So we're going to do a couple of things. We're going to use the transcript data to figure out the sentiment inside the transcript, and we're also going to pick out the customer's name inside of there. So thank you. So this one, what we're going to choose is we're going to choose sentiment inside one of the nodes, and we'll tell it the column that we're trying to detect the sentiment on. And we're also going to detect an answer based on a prompt that we're going to give it as well. So in this one, we're going to ask it, who is the customer? And we're going to extract that into initially a single column. So the transcript column is now going to be an array. And so when we pull that out, we're going to have the sentiment in one of them and the person's name in the other one, based on two models inside Cortex that we've got set up to do that. And we can see the output there. So furthermore, what we can start to do with this is just pass this out. So what we'll show next is, again, just a massive accelerator. We're going to create a staging node to plug into something like a Tableau or some kind of visualization tool. This is going to be our final set of data. But we're going to do something, we're going to flatten that data out really quickly. So we're going to use kind of, Snowflake's dot notation, but under the hood, we're going to do all that for you. We're going to generate that code to flatten out the name and the transcript sentiment into separate fields so that we can we can use them better for analytics. And in a second, once that's gone, we'll flip over to Snowflake and we'll see the outputs of that. So the outputs were basically, we have the person's name from the transcript now that we may not have had before. So we can be much more customer centric and customer 360 on those kind of things, and we can see exactly which customers, if we had a good score in guessing their name, we can also see the sentiment of the call that they called in about, and we can also kind of go further than that. And the next query is going to show us how we can maybe aggregate the sentiment across the different types of calls and the product that people were calling about. So a great visual for the guys in your business team and driving that value to them too. The sentiment is much worse around broken belt buckles when people call in. And again, really highlighting really great insight of something those guys should look at, and just the power of LLM functions in data pipelines. Thank you very much.
Yeah, awesome stuff, Scott. And really what that highlights is that's a 5-minute demo, basically building a pipeline with LLMs, and you can operationalize that pretty much instantly. But that's pretty much across our platform. It's how we live and breathe. Cool.
I think we're going to have to call it there. Andrew, Scott, please give them a round of applause.